Today, a quarter of the world's population, 1.5 billion people, connect to the internet. Over the next 5 years, there will be over 10 billion client devices and another billion users accessing hundreds of thousands of internet services, all competing for limited IT resources that will likely choke traditional infrastructures without a radically simpler, more secure, and more efficient way of doing things. Cloud computing offers that potential. New approaches to IT automation and the ability to rapidly scale computing resources offer IT organizations the promise to swiftly respond to the demands of users in a new, cost-effective manner. But there are challenges to overcome. There are real limitations in power, space, capacity, and bandwidth in today's data centers. There is also risk that closed proprietary cloud computing architectures will stifle innovation. Today, IT organizations struggle to share data between providers, to allocate resources automatically, and to ensure that the cloud-based applications maximize user productivity regardless of the device being used. Intel's vision is a multi-year evolution to deliver cloud-based architectures that enable federated, automated, and client-aware cloud services. No longer will clouds be constrained by proprietary protocols. Interoperable solutions that embrace standards will prevail. Visualize. Enterprises easily moving data and sharing services between private clouds and public cloud providers when they need it. Resources that are dynamically allocated and automatically optimized for maximum utilization and power efficiency. End-user devices that are automatically recognized by cloud services and receive cloud-based applications in the most optimal fashion. The foundation for this vision and the future of cloud computing will be defined by an open approach that delivers best-of-breed technologies combined with flexibility and choice from data center to client. In fact, global IT technologists are demanding cloud infrastructures that are open and interoperable. To turn this vision into reality, Intel has brought together a broad network of leading hardware and solution providers to rapidly build and enhance cloud solutions that are interoperable, multi-vendor, and embrace standards. These solutions promise to keep your data secure and safe, make your data center more energy efficient, and simplify the manageability of your cloud infrastructure while optimizing application delivery. Intel has a rich history of engaging the ecosystem and leading IT transitions. From defining open standards for networking, wireless, and connecting devices to your PC, to bringing volume economics to servers. The cloud brings forward the next major inflection for IT. And as a catalyst for change, Intel will rally the industry behind a vision that fulfills the cloud's true potential.
Imagine you could take your data center and unleash its potential, transform it into a powerful, highly automated IT resource. Imagine a data center that achieves new levels of availability, scale, and efficiency, that moves workloads seamlessly across your private cloud, service provider clouds, and public clouds. You don't have to imagine it. Transform your data center with Windows Server 2012, built from the cloud up.
As the person who led the engineering team that developed Windows Server 2012, I'm honored to take you on a tour of our newest release and discuss how it powers the Cloud OS, transforming and modernizing single servers all the way to global data centers, and demonstrate major innovations we've pioneered in the era of the Cloud OS. In fact, we built Windows Server 2012 with the Cloud OS in mind. Microsoft runs some of the world's largest data centers and internet-scale services. This uniquely positions Microsoft to pour all of that learning into our products and test them at scale and use our unparalleled experience in transforming data centers to address the needs and pressures of this new era of IT. No one else in the industry can say this. We've learned that modern data centers have 4 key attributes. They need to be scalable and elastic, share resources, be always up and always on, and have automation and self-service. With our experience in all 4 facets running in our own data centers, we built Windows Server 2012 with one goal: to be the industry-leading engine of the Cloud OS. It's the deepest and broadest release ever, built for companies of all sizes, whether you run a single server connecting to the cloud or a large data center. Let's start with scalability and elasticity. In modern data centers, services must span many servers and rapidly expand and contract automatically based on demand. Windows Server 2012 meets the scalability needs of companies of all sizes, 1 to thousands of servers. With Hyper-V scale, no workload is off limits. For example, Windows Server can now virtualize over 99% of all SQL databases, and it can support the largest VMs with 64 virtual processors and 1 terabyte of memory per VM. And announcing today 8,000 VMs per cluster, the largest in the industry. In terms of shared resources, cost is critical. To transform the data center, resources must be shared, optimize utilization across the entire data center and beyond. Windows Server 2012 Hyper-V has network virtualization and multi-tenancy and isolation built in. Software-defined networking enables you to isolate different business units, different customers, and different workloads on shared infrastructure with quality of service and resource metering. And for storage virtualization and thin provisioning, if you use a SAN, we've made enhancements with our partners using offload technology, ODX. Windows Server 2012 also enables storage pooling through a technology called Storage Spaces. It delivers highly available storage pools on industry-standard hardware. Let me pause for a moment and invite Jeff Woolsey up to show you how Windows Server can transform your data center. Jeff.
Thanks, Bill. Windows Server 2012 is about making businesses more agile, data centers more flexible, and providing the definitive backbone for cloud. But most importantly, Windows Server 2012 is about customer focus. We heard you loud and clear. You want to virtualize everything, even those workloads considered non-virtualizable. Workloads that require dozens of cores, hundreds of gigabytes of memory, are SAN attached, and with exceptionally high I/O requirements. Think Dynamics, Exchange, SharePoint, and massive scale-up SQL Server. With Windows Server 2012, we're redefining performance and scale, with support for up to 320 logical processors per server, 4 terabytes of physical memory per server, and up to 64 virtual processors per VM. In addition, you can see we've allocated 120 gigabytes of memory to this virtual machine, and Hyper-V will support up to a full terabyte of memory per VM. And whether this VM has been allocated 10 gigabytes, 100 gigabytes, or a full terabyte, it still costs the same. From a storage standpoint, virtual disk can now be up to 64 terabytes per virtual disk, which is 32 times anyone else in the industry. From a cluster standpoint, we now support the largest clusters in the industry. And as we expand this, you can see this cluster has 64 nodes. In addition, as we scroll down, you can see 8,000 virtual machines in a cluster. All of this built into Windows Server 2012. In terms of storage, whether you choose to use direct attached, file-based, SAN-based, or cloud-based storage, we've made huge investments in storage across the board. One of our key focuses is to make continuously available storage more cost-effective for businesses of all sizes. With Storage Spaces, you can aggregate storage resources and create flexible, resilient storage pools that can be easily expanded based on your business needs. Now here in the new Server Manager, you can see that the current storage space is nearly full. When I need more space, I simply click Add Physical Disk and add new disks to expand the pool. In this case, we've added a new disk to increase capacity, and also notice the hot spare option for additional reliability. We're going to add the disk, and you can see that in just a few clicks, we've increased my storage pool with no impact to running services and without downtime. Now let's move to network multi-tenancy. When it comes to networking, We're seeing a fundamental shift in the way that networks are deployed in the modern data center, enabling public, private, and hybrid clouds to use software-defined networking, or SDN. SDN is about using the power of software to manage, control, and operate your networks. With Windows Server 2012 and System Center 2012 SP1, you can easily and dynamically provision isolated virtual networks running on the same physical fabric. Let's have a look. Here you can see we have 3 different companies all running on shared infrastructure. Same servers, storage, and network fabric. In fact, 2 of them, Contoso and Tailspin, are using the same subnet and are still isolated through network virtualization. And that's only the beginning. In addition to network multi-tenancy, network virtualization solves a huge problem facing the industry: IP portability across subnets. Let's look at the physical network fabric that makes up the Wingtip hosting network. Here you can see that it is running across 2 different subnets. The New York subnet is 172.17.1.0, while the Seattle subnet is 172.16.1.0. Now let's go back to the VM and services view, and you can see that I have a server in New York and another in Seattle. And in fact, we created this little IP portability tool on top of PowerShell, of course, to show you these VMs and their IP addresses in an easy graphical view. We can see that the customer address for the VM in the Seattle site and the one in the New York site are both in the 10.2 subnet, while the underlying provider addresses are on completely different subnets. So now we're going to live migrate a VM across subnets from Seattle to New York. First, we right-click on a virtual machine in Seattle and select Live Migrate. Now we're going to choose all hosts so I can see hosts running in both environments. I'm going to choose the destination server in the New York site and continue with the live migration. We can also click on the View Script button to show the raw PowerShell if I'd like to copy and paste this for further automation. Now in just a few clicks, we're live migrating a virtual machine across physical subnets, all without service interruption. And if we go back to the portability tool, you'll see that the server has moved to the new site and the customer address, which is the IP address running within the VM, hasn't changed. But the underlying physical address is in a new subnet. With network virtualization, you can extend your IT to a new data center or to a service provider without having to re-IP your workloads and using your existing switches and existing routers. Network virtualization is game-changing technology built into Windows Server 2012. Back to you, Bill.
Thanks, Jeff. Boy, this is amazing stuff. Moving to always on, always up. A modern data center services must be resilient to hardware failure, software failure, and servicing. The software needs to be architected to handle failure without any service interruption. Windows Server 2012 lets you deliver the highest levels of service availability at much lower costs. We've made investments in SMB storage protocol and Hyper-V to deliver high-performance, highly available file-based storage. Our new Share Nothing live migration in Windows Server 2012 gives you complete VM mobility, letting you live migrate virtual machines with simply a network connection. To enable continuous availability during servicing, we have cluster-aware updating. You can now automate server updates and patching across a cluster of servers without impacting the service. Finally, we turn to automation and self-service. Automation and light site management are key attributes of any modern data center. Also, the ability to enable departments and users to self-provision. In Server 2012, we have delivered ubiquitous automation with over 2,400 new PowerShell commandlets, eliminating manual tasks, enabling you to manage servers at very, very large scale. Windows Server has built-in standards-based management. And we have a world-class management system with System Center 2012, which layers on the capabilities in Windows Server, giving you a policy-driven automation system to efficiently meet the new unparalleled levels of service you need. Many of you also want to connect to and use public cloud services. Let's see how you can extend the boundaries of your data center with another demo from Jeff.
Now let's take a look at the new scale-out file server. With the new scale-out file server, all nodes are active, and this architecture intrinsically provides more scale as nodes are added, and continuous uptime even when nodes are removed. It's a powerful solution. Now here we are running a real-world OLTP workload in SQL Server 2012. SQL Server is accessing its data on a 2-node scale-out file server. In perfmon, you can see the workload is generating a significant amount of I/O. Here in the Failover Cluster Manager in the Nodes tab, you can see both servers. Now while this OLTP workload continues to process, we're going to simulate a node failure on one of the continuously available file servers that is hosting the SQL data. Keep an eye on perfmon and watch what happens to the I/O. You can see that there was a momentary brownout while the node was removed, but SQL Server continued to process the OLTP workload without service interruption. And if I need to add more network bandwidth to the scale-out file server, well, just to add another node, live, without downtime. In keeping with our theme of always on, we've dramatically improved Hyper-V live migration. For example, Windows Server 2012 Hyper-V now includes shared nothing live migration, which means Hyper-V can live migrate VMs using just a network connection. In addition, we've also added the ability to perform multiple live migrations concurrently, limited only by the hardware you provide. To show you what I mean, here's a server running 120 virtual machines. Now, wouldn't it be great to live migrate 10 or 20 VMs at a time? Well, how about live migrating 120 VMs at the same time? Yes, folks, that's what you're about to see here. So, in case you're wondering about the hardware, the server is using a few 10 gigabit NICs, the new Windows Server 2012 NIC teaming, and the VMs are running on the Windows Server 2012 file server over SMB3. Again, all of this is built in to Windows Server 2012. Now, many of our customers have told us they can't grow their data centers fast enough. Essentially, they want a data center without boundaries. We want to help our customers create the continuous data center and transform the industry. Here's the new Windows Azure portal, and you can see a list of VMs, cloud services, SQL databases, and more. Let's create a new virtual machine from the gallery. Now here you can see a variety of choices from Windows Server to even different Linux distributions provided by partners. Let's choose my favorite, Windows Server 2012, and we'll give the VM a name. We'll set the password and choose the size of the VM, anywhere from extra small to extra large. Next, we'll give the VM a DNS name and storage count. We can also provide additional grouping for high availability, which I don't need right now, and I'm going to use the defaults and click the checkbox. And like that, Windows Azure is creating the VM to our requirements. Folks, the Azure VM role is making huge waves. Since the launch on June 7th, over 60% of all virtual machines deployed are from new customers. We're seeing tremendous growth here. With the ability to easily create and deploy VMs on Azure, let me show you how you can manage this from Windows Server 2012 on premises. So first, we're going to click on Add Other Servers to manage. Now we're going to click on DNS and type in the DNS name of the VM. Now this server appears as just another server along my servers running on premises. We can even right-click and add roles, monitor events, all using the new Windows Server 2012 Server Manager. With industry-leading performance and scale, major investments in storage and networking, and the ability to consistently manage all of your clouds, these are just a few of the reasons why Windows Server 2012 make the definitive platform for cloud. Back to you, Bill.
Thanks, Jeff. Wow, I am so excited, and isn't it amazing the connection between Windows Server and Windows Azure, where you can have a seamless experience. You've seen a lot in a very short amount of time, but it's just the beginning. There's much, much more. As I mentioned earlier, this is the broadest and deepest release ever, and our customers tell the story best. So let's hear from a few of them.
Availability is critical to us. We deal in very large-scale databases and data repositories. Some of the specific reasons that Windows Server 2012 was very exciting to us was in the area of file server capabilities.
With Windows 2012, I don't have to worry about file storage. It just works.
Where we're able to transparently take down a single node of the cluster, have our applications automatically move over to other nodes. Then we have plenty of time to work on the node we just took out of the cluster, do our patching, do any type of hardware maintenance that we need, bring it back online, and then let Windows Server 2012 rebalance the loads. It's not just a couple of little fixes, it's a huge release, and it's a huge different experience than what we've had before. I would call it revolutionary.
What we see now is really an embracing of technology by students.
The student body coming in, they're really technically savvy. Our infrastructure is growing all the time.
Network infrastructure for the university has changed dramatically with this increase in laptops and these mobile devices.
Windows Server 2012 is going to help us a lot, transform the way we do some of our outages. With our Server 2012 Hyper-V environment, we have a lot more comfort in patching Windows systems than we do with VMware-based hosts.
Now you can set at a cluster level to say, I want to patch this entire cluster, and you walk away and it does all that work for you. With Server 2012, I think Microsoft has pretty much leveled the field when it comes to hypervisor with virtualization.
We're able to easily move our VMs from VMware over to Hyper-V now.
With Hyper-V on 2012, it's right there, and then when you couple that with System Center 2012, you get this entire package that, for us, it's a no-brainer.
Outsourcery are a cloud service provider. We are based in the UK, but we have a global reach. Over the last 2 years, we've focused on being a pure-play cloud provider.
The way that we position ourselves in the market is that we've got a very high-quality, enterprise-grade platform for business-critical applications and workloads.
Our customers can run applications and services and actually achieve more in their business using the power of Windows Server and System Center together.
Currently, in order to isolate our customers, we have to provision VLANs and subnet. With the network virtualization feature, we basically have the ability now to run multiple customers on the same hardware with the same IP ranges.
Customers these days really want flexibility, especially when they're looking at kind of hybrid model of cloud. They want to be able to move things, migrate things from on-premise to a hosting provider like us to Azure.
Windows Server 2012 brings us a huge amount of new technology, new features, new capabilities.
I couldn't be more grateful to the customers and partners who participated in the development of Windows Server 2012. This release encompasses hundreds of new features, thousands of enhancements, and thousands of engineer years, all focused on one goal: be the industry-leading engine of the Cloud OS.
Hello again. As you know, I am Eli the Computer Guy, and today's class is NAS and SAN Introduction. So a lot of people get confused about what NAS and SAN are because they do similar things within the network environment, and so I figured, hey, let's do a class on introduction about these different things. So NAS is network attached storage, and SAN is storage area network. So basically, what both of these things do is they store data for your infrastructure. So way back when, way back in the day, 2002 or whatnot, we had servers, and servers are what stored all of the data essentially. So whether it was a Windows 2000 server, 2003 server, or Unix server, basically you had these servers. Then they started coming out with these custom devices in order to store data. So basically they started coming out with infrastructure that's entire purpose was to store data. Its purpose was not to do Active Directory, its purpose was not to do virtualization, its purpose was not to do VPN or IIS or any of that. All its purpose was to store data. So the first thing that you should understand is NAS. NAS stands for Network Attached Storage. Really, basically, at the end of the day, what NAS devices are they are essentially file servers. So they are essentially file servers that is all they do. You would not have a file server and then install other applications onto it. Basically, it is a file server. It's a NAS, a network attached storage device. All it does is store data. So basically with NAS, it is one unit. Its entire purpose in life is to store data. It may store 1 terabyte of data. It may store a few petabytes of data. But basically all it does is it stores data. Now the big thing for the definition of a NAS device is that you are using standard file transfer protocols in order to interact with it. So basically this is the equivalent when you set up a NAS as a shared drive on the network. So basically you share out whatever folders that you create on the NAS device, and they are accessed just like you would access a shared drive on a server. So you would be using the FTP protocol, the file transfer protocol, in order to interact with the NAS device, or SMB, CFS, Apple File Protocol, basically any of the standard protocols. So SMB and CFS, these are the protocols that allow you to copy and paste files and folders within a Windows network. So basically that is how you would interact with this NAS device. Basically it is a shared file server on the network. Now when you're dealing with NAS, there's a lot of different NAS devices out there. You can use things like FreeNAS. FreeNAS is a free network attached storage operating system. And the thing is with these NAS devices, with these NAS operating systems, is that they are specifically designed only to store files. Why that's important is because that means you're not going to be interacting with that server or device in any other way, so it will be more secure than other types of servers. So again, one of the big problems that you get into in the real world is you set up this beautiful Windows Server 2012 box, you install the file server, you install all this fancy stuff, and basically you know that as long as nobody touches this server, it is going to run very well for the next decade, as long as the power supply doesn't blow up. Well then, surprise, surprise, what happens is one of the employees comes in and decides to start surfing the internet on your wonderful Windows Server 2012 box, then gets viruses, then installs a screensaver, then does just a whole bunch of stupid crap on this computer, and all of a sudden you've got tons and tons of problems. Why? Because it's a Windows operating system, and people do stupid things on Windows operating systems. It's true, and a spaghetti monster. I've seen it time and time and time again. You walk into the server room and you see all this crap on the server and you're like, what the hell's wrong with you, right? Well, the nice part is if you use a NAS or a NAS operating system is that all it does is store files. So if somebody goes onto it, they can't look at porn. They can't download and install applications willy-nilly. They can't get onto the internet and check their Gmail. Why? Because it's a NAS unit, right? So that's one of the benefits of NAS units. Beyond that, since they're specially designed for storing data, they are simply better at it than many of the other server operating systems. Basically, they are, you know, when they create the operating system, they optimize it only for storing and transmitting data, being able to send and receive data. Therefore, it does that a whole lot better. So that's what a NAS is. A network attached storage device is basically a file server that's just an Uber file server that all it does is serve files. Again, like I say, you can use software such as FreeNAS in order to create your own NAS. This does not have to be highly customized hardware. You can go out and you can create a NAS device using just an Intel processor and hard drives and RAM and all of that. The main thing is with a NAS is that the operating system is designed to only be a file storage device. Now when we start talking about SANs are a different critter. And this is one of the things that people get confused about. So NAS is one box, right? NAS is a box that stores files. A SAN, or a storage area network, is basically a network of boxes to store data. So when you start using a storage area network, what happens is you connect numerous different devices, SAN devices, and all of them store your data generally in something like a cluster. So with that NAS device, if the power supply in the NAS device fails, if the RAID controller in the NAS device fails, if who the hell knows, the user somehow shoves a virus onto it and it fails, your data's stuck until you can get it back up and working. Now with the SAN, what is nice is basically you can create a cluster of these storage devices, and if any one fails, all of your data is still there. It is still accessible, depending on what the replication strategy is and what the redundancy is. You can have 1, 2, 3, 4, 5 entire boxes completely and utterly fail, but the data will still be there. You will still be able to write to the SAN. You will still be able to read to the SAN. For you, it will be relatively seamless, even if, again, an entire device fails. Now, the other important thing with the SAN and why the SANs are important is because you can actually map drives to the SAN. So again, when we're talking about network attached storage, NAS devices, basically it is offering up file shares on the network. S:shared folder, right? You know, same thing you've been doing for the last 20 years. When you're dealing with SAN, what is really cool is you can actually map to the SAN and have that folder on the SAN seem as if it is a local hard drive to your computer. So using Fibre Channel or using something called iSCSI, you can actually mount that folder on the SAN, and now it looks as if it is local to your server. Now, why this is important is because then you can install software. So basically you're sitting at your computer and you mount to the SAN. You could actually install software onto that SAN and it would seem as if it is running locally. Anything that you would want to do local, you could then do on the SAN. You could store it on the SAN and not worry about losing that data. That becomes very, very, very important, especially when we start dealing with virtualization. So let's go over to my little whiteboard for a second, just so I can explain some of this stuff, because I think when you see it on the whiteboard, it'll make a little more sense. So basically, when we're talking about NAS, NAS is a device. You have your computer, you go and interact with NAS, with FTP, or SMB, or CFS, right? If anything happens, it fails, and all of your data is gone. You can't get to it. Now, when we're talking about a SAN, though, a storage area network, this is a network of storage devices, and they become a cluster. So what that means is when you go to the SAN, you don't really know if you're going to this particular SAN device or this particular SAN device or this particular SAN device, this particular SAN device. What you see is just the SAN. And so you just go to the SAN. And now why this is important is because if this device fails, you're going to the SAN, you're not going to that device, so you may not even notice. If this device fails, you may not even notice because you are simply going to the SAN. You're not going to the individual devices. So as far as reliability and redundancy and all that, that's why SANs are absolutely awesome. The other thing that's great, the other thing that is so wonderful with SANs, and again, think about where I was talking about with that mount point for the servers, is anybody who has dealt with servers in the enterprise world, one of the most obnoxious problems you ever run into? One of the most obnoxious problems you ever run into is when you buy your server, you're going to put in a certain size hard drive, and it is going to seem huge, and it's going to seem massive. It's going to seem like the biggest hard drive you've ever could possibly want. And then when like 3 or 4 years, that hard drive is going to fill up, and then you're going to have to be figuring out how to add hard drive space to that server seamlessly to the end user. And so the problem is you have your normal server, and then you have the hard drive that gets all full up, and now you've got a problem. You have to migrate the data onto a bigger hard drive and then put it in? Do you have to do some tedious thing with you add hard drives and then you span volumes? It can just be a real pain in the butt, and especially when you're dealing with end users that want 100% uptime and don't want downtime, right? So when this hard drive fills up on a normal server, it's just tedious. It's tedious, it's horrible, it's nasty, but you don't want to go deal with that. But think about this. If you have this server, and you create a mount point to the SAN, so you're now storing all your users' data onto the SAN. What's the cool part with the SAN is is you can rather seamlessly add a new server with 10 terabytes of data and then just connect it to the SAN, and all of a sudden the SAN will now have 10 more terabytes of data. So now, instead of having to worry about all this stuff, you just added 10 terabytes of data storage to this SAN, and now you can just use it very easily. So again, remember, all of these are their own individual network-attached devices, and so you just add a new one with 10 terabytes of storage, or 20 terabytes, or 30 terabytes, or 1 petabyte. But basically, you can just connect it to the SAN, and now all of a sudden, you have all of that extra data at your disposal, or extra storage at your disposal. Now, the big thing with now, why SANs are becoming more and more useful that's the first part. The first part is basically you can add storage to SANs very, 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 very easily, because you're no longer dealing with individual hard drives, you're no longer dealing with individual partitions, you're dealing with entire boxes. So you can just add a new 10 terabyte box, and all of a sudden you now have 10 more terabytes in your SAN. You have to go in and do a couple of configurations, but believe me, doing a couple of configurations is a hell of a lot easier than doing a massive data migration, right? And if you need to pull an old device out of the SAN, you can basically just turn it off within the SAN management console and then unplug it and plug something new in. So it's very easy to replace storage now. Instead of worrying about RAID cards, instead of worrying about hard drives, you can just plug in entire boxes or pull out entire boxes. Now, why? The other reason that SANs are becoming so important is because of virtualization, right? So we have started virtualizing all of our servers. Instead of having 50 hardware boxes, 50 physical servers sitting in our data center, we now have 5 or 6 physical servers with 50 instances of server operating systems floating between all of those physical servers. Now, I've talked about virtualization before. I've talked about how with this type of virtualization, if one of the servers, one of the physical servers fails, how the instances of operating systems can automatically be migrated to other physical machines. And a lot of you guys have said, Eli, you're a liar. That doesn't make any sense. If the instance of the operating system is running on one physical machine, and that physical machine fails, well, then how does it hop to another physical machine? Eli, you're a liar. They really have. They've been kind of nasty at it. So let me kind of explain to you how this works. Let's go back to our whiteboard. So basically, what we have here is we have our virtual environment. And so these are the physical boxes. So we've got 4 physical boxes right here. And these are the hypervisors. So these are what are running the virtual machines. And so then let's say we have 10 instances of virtual machines. So basically, these instances are running on this hardware, or so it seems. What really happens is that these hypervisors are connected to the SAN. So the SAN over here actually, in fact, is where all these instances of the operating system are stored. What the virtualization software does is it goes to the SAN, it grabs an instance, and then it takes it to the physical machine that has the resources in order to use it. So let's say this one takes 2 of the instances, this physical machine takes, I don't know, 5 of the instances, and this physical machine takes 3 of the instances. So we have this one machine down here, this one physical machine down here, where nothing's happened. It doesn't have any instances running. So the instances are actually stored on the SAN, but they're being run on the virtual computers. Now, why this is important is because they're stored on the SAN. They're stored on the SAN. Stored on the SAN. They're not actually, they're run on the virtual, on the hypervisor. They're not stored there. So if this machine here fails, the virtualization software recognizes that, and it automatically will then turn the instances on a different machine that has the resources. So this is the big thing to understand with these SANs, is that the instances reside in the SAN and then are pulled into the hypervisor infrastructure in order to actually be run. That is what is going on. That's why this new virtual infrastructure can have so much redundancy. because the SAN is a cluster of storage devices that contain all the data, contain all the instances, contain all of that, and everything gets pulled out as it's needed. Now, you're probably asking, you're like, well, Eli, that doesn't make a darn bit of sense, because especially, you know, when I talked about that virtualization class, I talked about how if you pull the power supply out of one of those physical machines, the instance of a server will be up and running on a different physical machine literally so quickly that most end users won't even recognize it. So you're thinking, Eli, that doesn't make any sense. On a 10100 megabit per second network, if we're talking about networking, that wouldn't be fast enough. Even on a gigabit per second networking, that wouldn't be fast enough to transfer an entire instance. Well, what you have to understand when you're dealing with SANs is you start dealing with storage networks. So you will hear something called fiber channel. Fiber channel is something that is exceedingly expensive, and you will not see it until you're a big boy. And somebody trusts you enough to see it. So fiber channel is the main storage network that is used for these SAN environments. It is a fiber optic network, and it can run at it's at anywhere from 2 to 16 gigabit per second connections. So basically, you have the SANs. All those SAN devices are connected to a fiber channel switch using fiber optic cable, and then these servers and this whole virtual infrastructure are then connected to the fiber channel switch using fiber optic cable. So now you have all of these servers and the SAN devices all connected locally with fiber optic, and that is why it is so fast. So when you connect to the virtual servers, or when you connect to the hypervisors, you're using your normal TCP/IP, Ethernet, Cat5, Cat6 infrastructure. That's what you're using. So on your side, it's TCP/IP4, TCP/IPv6, Cat5, blah, blah, blah. On the other side, on the data storage side, it is generally fiber channel, fiber optic, 16 gigabit per second connections. So that's the important thing to understand. Again, when we start talking about like things like networking in the enterprise environment, we start talking about different things. So different devices are connected in different ways depending on what's going on. You connect to the servers, you connect to the internet, you connect to the print server using TCP/IP and Ethernet. These devices all connect using fiber channel. Now there is a poor man's version of this storage networking protocol. There's something called iSCSI. So if you wanted to start playing around with this kind of stuff, iSCSI is a storage protocol that runs over standard TCP/IP. The only thing with that is it's going to be a lot slower. It's obviously not going to be 16 gigabits per second because you're running over copper. You might get 1 gigabit per second. But if you want to start playing with the SAN technology in your little lab, iSCSI is what you are going to be doing. Basically, you create an iSCSI connection on whatever NAS or SAN device, basically SAN device that you have, and then you can connect to that using Windows Server 2012 and a lot of Windows servers and Linux and all that. But iSCSI will be a different class. But this is the basic idea behind NAS and SAN. So what you have to understand about NAS is basically NAS, Network Attached Storage. These are devices, essentially these are file servers. Essentially that's what it is. At the end of the day, it's a file server. That's it. The main thing to understand with NAS is that it uses the standard file transfer protocols, FTP, SMB, CFS, AFP, one of those things. Basically, you have to connect to it with some other type, of network sharing software in order to be able to do anything. With SAN, storage area networks, you're actually able to mount to the SAN. You're able to mount to a folder on the SAN as if it is a local hard drive. Then, when you have the SAN, basically you have a cluster of devices. Those clusters of devices, if one fails, you don't notice. You can install a new one, you don't notice. Basically, you have abstracted the data storage layer from the computational layer, and now you can deal with the data very, very, very easily. Again, when you're dealing with SANs, generally, you're dealing with something called fiber channel for its network infrastructure. In order for all this stuff to happen so quickly, again, you're talking about anywhere between 2 to 16 gigabits per second. The thing for you guys to realize is a lot of you guys will probably never see this because it's exceptionally expensive equipment. I mean, just yeah, it's just exceptional. I mean, we're talking lots of money. I mean, we're talking about like real SAN devices. We're talking about $20,000 device for the individual device. That's not including the switch, and that's just one. So if you want to connect 10 of these plus a switch, plus connect it to the virtual servers, the hypervisors, you're talking about $250,000 to $500,000 without really blinking. So just realize the real SAN, real fiber channel is that expensive. If you want to try to start playing with this at home, you can use something called iSCSI, and of course we will have an iSCSI class later. But that is basically the introduction to NAS and SAN. Again, a very important concept nowadays, and again, this continues the concept of abstracting the different layers of computing and creating infrastructures that only deal with those layers. So you have the hardware layer, you have the processing layer, you have the data storage layer. Before, everything was on one server. So you had one physical box, you had the operating system installed on that physical box, you had the data stored on that physical box, everything was on that one physical box. The power supply failed, you're screwed. If the CPU failed, you're screwed. Now we're separating all those things out. So the data is in its own cluster. The hardware is in its own cluster. The virtual instances migrate at will. So now we're pulling all those things apart. It makes it easier to manage, maintain, and if there is a failure, now most of the time you don't even notice. You know, now like with a SAN, if one of the SAN devices fails, you just unplug it, you yawn, you go home. When you come back in the morning, you order a new one, and 2 weeks later, you install it, right? Whereas if a hard drive fails on your server, you got to fix that right now. So that's why this stuff is important. So as you know, I am Eli the Computer Guy. This class was NAS, Network Attached Storage, and SAN, Storage Area Network Introduction. As always, I enjoyed teaching this class, and I look forward to seeing you at the next one.
Hey guys, it's Dave from Computing Forever, and in today's video I want to talk to you about what I foresee as some of the dangers of cloud-based storage solutions. So this is storing your personal information online, effectively a backup or even maybe a primary copy of your hard drive online. Now I've really been inspired to make this video based on another video made by my friend Harry iHarrison30, who had some really bad experiences with an online cloud storage company. He was storing a whole bunch of personal information online, and the long story short is that they contacted him and sent him an email and said that they would be closing his account, and he would have something like 30 or 60 days or something like that to take down all his files, or they would be automatically deleted, which was quite shocking. And the reason for doing this was because their algorithms that their customer care people were using detected that he was using this account, this personal account, for business purposes, which he clearly wasn't. There was nothing up there that was business related. It was all just personal, family files, family videos, family photos, things like that. So this is an issue that he's dealing with at the moment. He's made a video about it. I'll include an annotation and a link below so you can check that out and learn a little bit more about his story, and feel free to share your own experiences. Really, my worry about cloud storage, and I've spoken before about, and I'm not going to get into the usual issues, which is you know, what happens when these companies go out of business? What happens to your files? What happens when I don't have access to Wi-Fi to actually get at my files? Those are all very real things. And of course, we won't even touch on the fact that there's always the fear that these organizations can be corrupt, that they can give out your information, they can sell on your details, or you can get hacked. I mean, these are other things. Can these cloud storage servers be hacked? And can they get access to your information that way? Those are all valid complaints, but what I'm really concerned about is kind of how the consumer zeitgeist has changed in recent years. So, and I think social media is largely responsible for that. So when the internet was first commercialized in the early 90s, mid 90s, We were all told, be very careful online. A lot of weirdos out there. Do not share any personal information. Don't include your real name. If you're on a chat room, if you're in the forums, use a fake name. Use an avatar. Certainly don't put up your photographs. Don't give your date of birth. Don't do all these things. And social media has made us more, social, as I've said before. I don't agree with that at all. Spending all day on tablets and smartphones and on the computer. But they have made us, they've kind of softened us up and primed us for where we are now, which is where we just freely giving away our information to marketeers, to companies, to businesses. So we're putting up information about what we did this weekend, where we work, our interests, our friends, our family, everything. I mean, it's insane. So the next logical step of that is cloud storage. Now you might say, well, Dave, it's only cloud backup. What's the harm? Well, there's a number of areas of concern there for me. And it begins at cloud backup, and then it eventually becomes like Chromebook type technology. Maybe they haven't taken off right now, but in the future, maybe tablets and smartphones and laptops won't have their own inbuilt storage. Or they may be hybridized to a certain degree, reliant on the cloud to get most of your data, to retrieve most of your information. We already have this with your Gmail account, and I suppose YouTube to a certain degree is the cloud as well. You're storing your videos there. So we are using this stuff, Facebook and Twitter and Pinterest and all these other social media forms are a form of cloud as well, because there's some degree of storage. But in the strictest sense, cloud-based backup for many people may become cloud-based primary storage as well. So as Wi-Fi becomes more prevalent everywhere, and we're constantly connected all the time, and it'll get harder and harder to find a place where we don't have a signal, it'll just become, I suppose, more of an opportunity for cloud-based storage to become a big deal. And in that respect, it means that these devices will become nothing more than dumb terminals reliant on the internet. So I think social media has played into that. It's basically made us much more trusting, overly so, of these organizations who may not necessarily have our best interests at heart. I mean, how much of a jump is it to say? I mean, if you have a Gmail account, you know that you occasionally get these little ads, or things that you've bought on Amazon, for example. You may get alerted to things. Oh, you like this, maybe you like this. They target based on the content of your emails, or based on the content of, if you've got, as I say, an Amazon or an eBay account, based on things that you purchased. So what's to say that they don't conduct some sort of analysis on the data that's on your hard drive? And this is exactly what happened to Harry. They were able to, scan his files, and it's crazy to think that they were able to perform that analysis. I mean, if a few years ago, and the only reason cloud-based storage has really taken off is because of the ubiquity of Wi-Fi and the fact that internet connections are so much faster than what they were before. So upload speeds are so much higher, download speeds. So it's easier to store a lot of information in the cloud. Prior to this, the idea of putting your information in the cloud was absolutely ridiculous. No one would do it. No one would take that risk. The idea, it's kind of like saying a few years ago, here's my hard drive, and give it to a company, and they'll, like giving them an external hard drive, and they'll look after it for you. That's absolutely insane. It's insane to think that we're doing this. And what happened to Harry, I mean, that's a microcosmic version of what may happen in the future, which is data mining. That the fact that someone can go through your data. Now, we've already had this issue, the NSA and people's personal information, their web activity and their behaviors online being monitored. Well, what about, we talk a lot about big data in social media. What about the big data of cloud storage? I mean, that's got to be even bigger than anything that they could ever hope to get out of you when it comes to your Facebook account or your Twitter or your LinkedIn. If you look at the potential for data mining and big data analysis, maybe they won't go into specifics about what you have in your hard drive, but there are lots of analytics companies out there who are chomping at the bit to do something like this. And they'll produce like annual reports, for example, and surveys saying, in the United States, 86% of people have this on their hard drive, or 73% of people are using it for games or for storage of documents and all this kind of stuff. And you're thinking, well, that seems all benign enough. But the point is that we are surrendering our privacy. It's not being taken from us. We're surrendering our right to have it. We're acquiescing here. We're just simply giving in. We're just simply saying, sure, absolutely, let the floodgates open. Where does it end? So they may not be able to do much with our data because they'll have all their own legal terms and conditions and they'll be bound by law. But there are obviously still those concerns. And there's a lot of organizations out there who are, some of them are faceless, you don't know who they're representing. And you obviously have to be extremely cautious. And this is obviously what's happened to Harry recently. And I'm sure that he's not alone in this. I don't think that there's any doubting that we have become all too complacent when it comes to our data and our personal information on the internet. And I think cloud storage is just another gray area and something that we're going to have to deal with in the future. It's just all too easy to actually get a cloud account. I mean, you're offered cloud storage and quite a bit of it, often for free, from the likes of ISPs. When you buy certain mobile devices now, you're being given heaps of online cloud storage as well. And some of it, in terms of responsibility that these organizations take, some of them are obviously trials, but the responsibility they take really comes down to, the old adage of you get what you pay for. So if it's a case of you getting it for free, well, what's the catch in terms of, I suppose, the integrity of your data? And I think in the future, if it does become a case that we are reliant on cloud storage and you are obviously paying a monthly subscription or whatever it may be, you're effectively paying for something that you were once getting for free by having an internal hard drive. So guys, those are my thoughts on cloud-based storage and its potential dangers. Do you agree with me or do you disagree with me? Let me know below in the comments. And of course, be sure to hit that like button because it's always appreciated. It helps to keep this show going. If you enjoy this video and you'd like to see more, please hit that big yellow subscribe button in the bottom right hand corner. And of course, there's a couple of videos over here you can check out too. And like, favorite, and share this video. You can follow me on Twitter at Lax78. Computing Forever is over on Facebook and Google+. And I will see you in the next video. Bye-bye.
So imagine you have a dog, and your dog's name is Frank. It's a strange dog name, but just go with it. You and Frank are best pals. You go on walks together, Frank always walks faster, but still, you really love Frank a lot. You only have one photo of Frank though, this goofy shot of Frank at his birthday party, drooling on the cake. And because you love this weirdly named dog so much, you're worried you might lose this photo. So you upload the photo, your favorite photo, to one of your favorite photo websites, like Flickr, Facebook, or Picasa. And without realizing it, you just started cloud computing. But what does that mean? When you put Frank's photo online, you could picture a giant cloud coming down to vacuum up this photo off your laptop. Then the photo of Frank, birthday hat and all, lives up in the cloud until you need to look at it again. You log onto Flickr or Facebook, and there's Frank. You can see him from wherever you want, from home, from work, even on your phone, in case you start missing Frank during your lunch break. At first, the cloud seems like magic, but it's not. The photo of Frank isn't flying around in the sky. Frank's photo actually lives in a secret warehouse full of computers. These warehouses are called data centers, or server farms, and they're popping up all over the world, just like crops. Inside one of the computer warehouses, there are rows and rows of refrigerator-sized computer towers that are way more powerful than your home computer. It's hard to know exactly where your photo of Frank may be once it's in the cloud. That's because it may be in a dozen of these warehouses all at once. Frank may be chilling in Paris or hanging out in India. There's really no way to know for sure. You just have to trust a web company, like Google or Microsoft, to keep Frank safe. There are a bunch of reasons to do this. The first is that, well, you only have one photo of Frank. It's on your laptop, and if that laptop breaks, if an alien comes to steal the data, or if your apartment melts when a volcano erupts, you're out of luck. No more Frank, no more memories. But when Frank's in the cloud, he's stored not just in one place, but all over the place. So you're less likely to lose him. You also can access Frank's photo from anywhere. You can send a link to some of your friends so they can see Frank too. That's just one of the many powers of cloud computing. And it's not just you and Frank. Entire businesses are running in the cloud. There are plenty of reasons to be scared of the cloud too. But for now, you decide to trust the cloud as backup. If Frank's happy, then you're happy.
New startup Nicira has officially launched its software that will reportedly disrupt networking giants such as Cisco and Juniper Networks. Nicira is a product of OpenFlow, and its software is called the Network Virtualization Platform. The software-based system creates virtual networks in cloud data centers, which could save companies millions of dollars. And to talk more about this highly anticipated software, Nicira's CTO and co-founder, Martin Casado, is joining us now by way of Skype. Thank you so much for chatting with us today, Martin.
Thank you.
Well, this software launch is gaining quite a bit of attention in the tech space. So what is it that makes it so exciting?
So what we're doing is we're decoupling applications from the network, much like applications have been decoupled from the server. And what this means at the end of the day is, while compute virtualization provides a lot of benefits from the perspective of a server, if you kind of zoom out your perspective to that of a data center, you lose a lot of these benefits. And the reason is because applications are still coupled to the network. So they can't, for example, move to different places. They're limited in what types of applications they can run. So we remove these bottlenecks. And as a result, we allow the benefits of server virtualization to be able to extend to the data center.
Okay, so this transferring of workloads between data centers, it's no small achievement. So how does it work?
So the simplest way to think about it is, like, we take these workloads and we put them into a world where everything they see is virtual. So today, if you have like an application or a virtual machine, it can see the physical network, and therefore if you move it, it can see that change, and that disrupts communication. What we do is we place it in an environment where everything it sees is virtual. So if we move it, for example, between one data center and another data center, it doesn't know that the world has changed, and therefore all of the communications goes undisrupted.
It's very interesting. Well, now tell us about OpenFlow, which is the technology behind Nicira. What does it do?
Sure. So the best way to think about OpenFlow is it's a standard method of communicating to switches. So what Nicira does is Nicira controls a network and network elements to give this illusion of virtualization. And the way that we talk to the switches is using OpenFlow. But what's important to remember is OpenFlow is actually a fairly small part of a larger solution. So I like to liken it to USB. So if you have a mouse that you use to drive your computer, for example, that mouse communicates to the computer using USB. So it's a very useful piece. However, the intellectual property is actually in the mouse. That is where kind of the real innovation works. And then the protocol used to communicate is just, it's a standard that's nice because it gives vendor independence and many can use, but it doesn't actually add to the innovation of the resulting product.
Right, and I understand that even though the software just recently launched, that it's been shipping since last summer, right?
That's right.
And already Nicira has customers on board like AT&T and eBay. So what have these companies found in using the platform?
Yeah, so I like to take kind of one of the quotes that we got from eBay. So today, in order to deploy a new application in a non-virtualized network, it often requires a lot of manual interaction with the network, which means you've got to go out and you've got to find the switches and you've got to configure them. And from eBay's standpoint, previously it would take roughly 7 days in order to do this configuration. Now, in the era of the cloud, that's just too much, right? We want to provision these in seconds or minutes. So with Nicira, when a new application comes up, it only takes seconds or minutes to configure a virtual network, not something like 7 days.
So I guess that's why Nicira's CEO has called this the missing piece to cloud computing.
Yeah, that's right, and I think that to kind of focus on that just a little bit, which is we've virtualized compute, and if you look at a server, we've virtualized a CPU, we virtualized memory, we virtualized storage, but we actually haven't virtualized the network. And so to really take advantage of compute virtualization and to really gain the benefits of the cloud, you need to virtualize every aspect of infrastructure in a data center, and the one that really has been the long pole has been the network, and that's the piece that we tackle.
So what makes Nicira confident that it can replace physical network innovation that really took decades to build with this virtual software?
Right. So this is a super question. So when compute virtualization came out, it didn't actually replace or change CPUs, right? It augments it and it supplements it. And so we do the same thing with physical networks. So we don't change physical networks. We don't require any change of gear. We add a new layer which uses this in a way that's more flexible. And so I think that the right way to think about it is similar to how server virtualization happens, which we augment and supplement, but we don't replace.
Okay. So what will this mean then for companies like Cisco and HP and Juniper Networks?
Yeah, so a lot of the traditional vendors continue to build on the existing model of networking, which is how do you build good physical networks. And because this is not what we do, we interoperate with all physical networks. We're almost tackling a different problem space. And so you will still continue to have vendors building great physical gear. Now, what we focus on is on customers, and our customers do want choice between vendors. Like they want to be able to choose between any of these large vendors. And so if they use Nicira MVP, they're able to choose between any of these hardware vendors, and all of them would provide good services, but still use ours. And we provide a lot of the flexibility and the agility on the provisioning side, on the application mobility side. And so, in the future, you will have both the virtual networking layer, which will be provided by companies like Nicira, and then you'll still have the physical ones provided by the traditional vendors.
Okay, so it's instead of a replacement, it's just a complement almost.
That's exactly right. That's exactly.
Okay, well, in a network computing article, the CEO of Embrain said, quote, Nicira is doing some very interesting things in the realm of scaling layer 2 and layer 3, but when it comes to scaling network services, it's going to be a different animal, end quote. What is your response to this statement?
Yeah, no, I think that this is. I'm guessing this is Dante. I think that's actually that's right. So when you scale L2 and L3, you use certain approaches, and when you work on virtualizing services, then you have to kind of use somewhat different technologies. And so from our standpoint, we don't like to talk about futures very much, but we've already virtualized some services, and we'll be virtualizing more. And in the next couple of months, you'll see these come out. And I very much agree that it does take some different approaches to do this correctly.
All right, so as far as the future, though, we can expect more development from this?
Yeah, absolutely.
All right, we look forward to it. Thank you so much for talking with us, Martin, and best of luck with the venture.
Thanks so much. I appreciate it. Thank you.
You're very welcome. Reporting for WebPro News, I'm Abby Johnson.
We'll start off by defining virtualization. I'll go more in depth into server virtualization. I'll talk about what a hypervisor is and how it can help you. Then we'll cover Type 1 versus Type 2 hypervisors. Once you're a virtualization administrator, I'll show you what it would look like for you to administer a virtual infrastructure, and then I'll cover some other types of virtualization that you should be aware of. So with that, let's get started. Before you start learning about anything, you should first have a definition of what it is. So let's start off by defining virtualization. And the textbook definition is that virtualization is an abstraction layer. But that doesn't mean a lot to me and to many other people as well. So what that really means is that the operating system no longer has to be bound to the server or the PC that it runs on. The OS is abstracted from the hardware. In other words, the operating system isn't installed directly on the hardware, and it's not connected directly to that piece of hardware, that PC, that laptop, that server. The operating system isn't installed directly on that. Instead, there's this layer in between the physical server and the operating system that you would normally install called the virtualization layer. If you're using VMware's solution for virtualization, that would be VMware ESXi or ESX. So as you see in the graphic here, you've got the physical server on the bottom, you've got the virtualization layer above that, then you have these containers, these little blocks called virtual machines. Those virtual machines are where you actually install the operating system that you're used to installing on the physical server, and then inside that operating system, of course, you would install your applications. So look at all the virtual machines that are running on that one physical server. Think about all the different operating systems that are inside those virtual machines and how all those different now virtual computers are able to use the same physical computer. And this type of virtualization is called server virtualization, and that's the most well-known form of virtualization. And that's mostly what we'll cover in this video training course on virtualization, is server virtualization, because it's by far the most popular, and it's the type of virtualization that you should start learning about first. So it's server virtualization that makes it possible for the operating system of a physical server to run on the virtualization layer. And that virtualization layer, or virtual layer, by the way, is called the hypervisor. Now, that allows you to run multiple virtual machines, or VMs, as we'll call them, each with their own operating system on that same physical server. So you've got the virtual host, which is the physical server with the virtualization layer on it. So that virtualization layer is the hypervisor. And there's different brands of hypervisors out there, some from Microsoft, some from VMware, some from Citrix. Those are all virtualization solutions, or server virtualization solutions, that you would install on the physical server, or the virtual host. Then on top of the virtual host, you've got multiple virtual machines. So you saw those little blocks over there on the physical server. Those are the virtual machines, and each guest operating system is running inside the individual virtual machines. Now let me give you a little bit more definition of what a hypervisor is. The hypervisor creates that virtualization layer, and it makes server virtualization possible. It contains what they call the Virtual Machine Manager, or the VMM. So the VMM's job is really to manage those multiple virtual machines that are running on the single virtual host. So again, multiple virtual machines on just one physical server, or one virtual host. So examples of hypervisors would be VMware ESX or ESXi, which are part of VMware's vSphere. There's Microsoft Hyper-V. There's VMware Workstation. There's VMware Fusion, which runs on the Mac operating system. There's Virtual Server and Zen Server. And I'll be going into these in more detail in this training course. I mentioned briefly that one of those hypervisors runs on the Mac operating system. Well, that sounds kind of strange because I just got done telling you that the hypervisor is loaded directly on the hardware. And the confusion lies in that there are two different types of hypervisors. There is what you call a Type 1 hypervisor, which is loaded directly on the hardware. That's the picture you saw back here, right there, where you've got VMware ESXi or ESX loaded directly on the physical server. That's a Type 1 hypervisor. A Type 2 hypervisor, on the other hand, would be loaded on, let's say, your desktop or your laptop computer, just like any other application. So examples of Type 1 hypervisors are Hyper-V, ESX and ESXi, or Zen Server. Examples of Type 2 hypervisors are VMware Workstation, Microsoft Virtual Server, and VMware Fusion. So the top three, Hyper-V, ESX, and Zen Server, are all loaded directly on a physical server, just like you load your Windows operating system. The bottom three, the Type 2 hypervisors, are loaded inside an operating system that's already running on the hardware. So maybe you have a server that already has Windows Server 2008 in it. You could load Workstation on top of that and then run virtual machines. Same thing with Virtual Server. VMware Fusion, on the other hand, would be loaded on a Macintosh system like a MacBook Pro or a Mac Mini, let's say a desktop computer, and then you would load Fusion in the Mac operating system. And at this point, you might be saying, well, the Type 2 hypervisors sound much easier to use. I just load an application in my local operating system, and I can run all these virtual machines on top of it. Maybe I could run all the servers in my data center off of my laptop. Well, it doesn't work quite like that. The bottom three, the Type 2 hypervisors, don't perform as well as the Type 1 hypervisors. And that's because that operating system layer is in between the virtualization layer and the physical hardware. So there's greater overhead in using Type 2 hypervisors, which really means you can't get as many virtual machines on the same piece of hardware. And another way of saying that is that the consolidation ratio with Type 2 hypervisors is much lower than the consolidation ratio with Type 1 hypervisors. So in other words, you can't get as many virtual machines on the same piece of hardware if you use a Type 2 hypervisor as you can with a Type 1 hypervisor. So Type 1 hypervisors like Hyper-V, ESX, ESXi, and Zen Server are to be used in the data center. That's where you have a dedicated physical server. You load these virtualization products or these hypervisors on that server, and then you consolidate as many physical servers as virtual machines onto those virtual hosts using the Type 1 hypervisor. That's because you're going to get the best performance with those Type 1 hypervisors. On the other hand, Type 2 hypervisors are still very useful, because if you just want to run a couple virtual machines, let's say on your laptop or your desktop PC, the Type 2 hypervisor is the way to go. You could run an Exchange virtual machine or a web server or a Linux virtual machine inside Windows using these Type 2 hypervisors. So there's tremendous benefits in the Type 2 hypervisor, but it's meant for a desktop or a laptop system that already has an operating system. You already have applications, maybe your email, your web browsing, your Microsoft Office applications. They can all be loaded on there along with the Type 2 hypervisor that's going to give you access to run more virtual machines. And again, I'll be demonstrating many of these hypervisors in this video training course. Moving on, let's now talk about how you administer enterprise virtualization. So this is a graphic, thanks to VMware.com, that lays out the typical VMware virtual infrastructure. On the bottom down here, you have what they call private cloud resource pools. So private cloud resource pools, just think of these as the servers in your data center. VMware is calling that now the private cloud. So if you have servers in your data center, that's the private cloud once you load virtualization on top of them. So the private cloud resources are the CPU, the disk, and the network resources that are available on your physical servers in the data center. On the right-hand side on the bottom here, you have the public cloud. We'll be talking more about cloud computing in a later lesson. So loaded on top of the private cloud resources, you have VMware vSphere. Assuming you choose that option from VMware, it's a Type 1 hypervisor. And VMware vSphere has different types of services, or you can just think of them as features included in vSphere. So there's infrastructure services, which is really ESX and ESXi. The features they provide, like the distributed resource scheduler, memory over commitment, there's application services, things like vMotion, high availability, data recovery, security, and scalability features. All these are just features inside VMware vSphere. You don't have to worry about those right now since you're just getting started with virtualization. vSphere has all these different features. On top of it, there's a management layer. That's the VMware vCenter server. Basically, it's just a Windows application that you go to manage multiple ESX servers or multiple physical servers running VMware's virtualization software. And then on top of those servers, you're running your virtual machines and your applications inside the guest operating systems. So if this graphic seems a little confusing, let me now go over to an actual vSphere client that I've connected to a vCenter server, and you can see the virtual machines and the ESX and ESXi servers in the virtual infrastructure. Here I am inside the VMware vSphere client. This is the application that a VMware administrator would use to administer a VMware virtual infrastructure. On the left-hand side, I have my ESX servers. These are the physical servers. And then underneath that, I have all my virtual machines. Thus, I'm able to run all the virtual machines you see on this list inside just 3 ESX servers, or 3 physical servers, with a lot of room for growth. On the other hand, if you are using Microsoft Hyper-V, this is the application called Hyper-V Manager that you would use to administer a Hyper-V server. Inside this one physical Hyper-V server, today I just have one virtual machine, but I have plenty of room for growth. Just like the vSphere client, with this application you can create new virtual machines, you can turn off your virtual machines, reboot them, take snapshots, which I'll talk about a little bit later, and even clone or duplicate existing virtual machines. Of course, I can also access the console of the virtual machine from this application, just like I would access the physical server console if I wasn't using virtualization. So that's how you administer enterprise virtualization. It's real simple. There's a client application that you use. You connect that client application either to a centralized management server or to the individual physical server that's running the virtualization software. From there, you can create and administer all your virtual machines running on that host or across the entire virtual infrastructure. Now, I mentioned earlier that there's other types of virtualization besides just server virtualization. There's desktop virtualization, network virtualization, I/O virtualization, storage, and even application virtualization. With desktop virtualization, you're virtualizing end-user desktops in the virtual infrastructure or in the data center, just like you virtualize your physical servers using server virtualization. So the end users would then use thin client devices to access their virtual desktops that are now in the data center. With network virtualization, you're virtualizing the network. Now, basics of network virtualization are required for server virtualization, because if you think about it, you've got all these virtual machines running on a single physical server. Those virtual machines have to communicate with one another, and then they have to communicate to the physical network. And network virtualization is used to do that. But there are more advanced types of network virtualization, even where you have Cisco switches running virtually in the virtual infrastructure. With I/O virtualization, you virtualize storage and network protocols onto a single communication path. So in your data center, instead of having, let's say, 4 network cables and 2 fiber channel SAN cables that go to every server, you can consolidate that all onto a single cable or 2 cables if you need redundancy. Then you'd be able to dynamically add and remove virtual connections to that single physical server using I/O virtualization. With storage virtualization, you virtualize the storage servers so that they're decoupled from the storage hardware. So instead of having a physical storage device, like a storage area network or a network attached storage or NAS device, that would be virtualized as a virtual machine, and then you would access that storage over the network. These are called virtual storage appliances, or VSAs. And then finally, there's application virtualization, which is virtualizing applications so that they're decoupled from the operating system. So instead of having to install, let's say, Microsoft Office, this large application that's installed into the operating system and modifies the registry, what if you could run those individual Microsoft Office applications just as single executables, just a single Word.exe? You double-click that, and it runs Word without any installation. You could run it over the network, you could run it over a thumb drive. All these things are possible with application virtualization. In summary, when it comes to these other types of virtualization, I want you to know what's out there. I want you to know that all these exist. But I encourage you to first learn about server virtualization, because honestly, that's the best place to start, and that's where you're going to get the most bang for your buck, because it will help you as an IT administrator and also help your company to save money and get things done so much faster.
Hi, this is John Qualls with BlueLock, and today I really want to show you how we leverage virtualization to enable the BlueLock cloud. So the first thing you're going to start out is with a facility. So that's what this right here is going to represent. And then in our infrastructure, when it comes to communication, we need to have the ability to route that communication, and then the ability to secure that communication, and the ability to distribute that communication, right? So router, firewall, switch. And then from there, we're going to introduce how we typically would have bought some servers. So this is a traditional approach. Now, some of the challenges with this is these underlying resources are running at maybe 10% utilization. So we're going to introduce virtualization, and for each one of these physical, we're actually going to introduce virtual servers. And those virtual servers allow us to remove these two. Now, what we do is we can actually take the other components and virtualize those also on the same stack. And what this does is not only then make that super efficient, this underlying piece here, but it allows us to be very mobile, and later on we may do something with that to leverage that to solve other problems. How do we then enable the cloud to gain other value that we can for this environment? So what we do is we introduce all these resources here in the cloud, and what that allows is that when there's a seasonal need to allow this infrastructure to grow, or maybe a burst need, that we have the ability to take this and move it around inside the cloud here to make those resources really hum. So I hope I had an opportunity to show you how you can get your resources efficiently here, and how those resources can scale up or down with your specific business needs, and how you're able to not use your capital dollars to get to those resources in today's economic environment.
So, This was my single mode of transportation from birth to 10th grade, the family station wagon. Yeah, it smelled like it looks, not good. Wood paneling, vinyl seats, apparently state-of-the-art dashboard that told my dad everything he needed to drive. Miles per hour, RPM, gas, oil, when are we gonna stop to go to the bathroom? Never light comes on. Now, if there was a problem lurking somewhere in that beast, we were only gonna figure it out when we smelled smoke or saw our transmission lying on the road in the rearview mirror. Today, cars are like big rolling computers with millions of lines of code and dashboards that look like Times Square with lights and chimes and little icons look like a fried egg or a bird cage. I don't know. But when one of those lights come on, you got no idea what it really means. The only thing you know for sure is that there is no way that you can fix it. It's the same with IT dashboards. Okay, we either get a flood of information that we can't possibly process or correlate, or we get like an overly simple gauge that just says, hey, something's wrong. Cool. That helps, but it doesn't tell us what caused it, or if it's gonna happen again, or how bad things really are, okay? And then, in this situation, which is called my life, the symptom that I get first is just like the smell of smoke in the form of a call from my boss, which is always great, because he only calls to give me compliments. That's sarcasm. See, a dashboard is only as good as its ability to bubble up the information we need to drive our IT environment properly while letting us drill down into the data. And when there's a problem, figure out what the heck's really going on. That's the beauty of vCenter Operations Management Suite Dashboard from VMware. It takes millions of metrics from across our virtual infrastructure, crunches them and correlates them and bubbles them up. Remember the bubbles? Bubbles are good into 3 key metrics or badges. Health, an up-to-the-minute look at what's happening right now, from our overall environment down to an itsy-bitsy, teeny-weeny little individual VM. Risk, what's been happening that might lead to trouble tomorrow, or in a month, or a year from now. Let's figure it out ahead of time, guys. How's my birthday look? And efficiency. How well are we using what we've got? Because the cloud isn't just about agility, it's also about saving dollars and cents, or yen, or euros, or whatever our parent company happens to be trading in this week. And if you're Rick, Star Wars figurines and collectibles, should have left them in the box, man. Be worth more. Now, from these badges, we can click down into any component at any level for more information when we need to. And that's all from a single role-based customizable dashboard that ensures that we're not gonna get lost in the middle of nowhere with the hood up and our careers lying, smoking in the road behind us, because there's no chance that we might run out of gas, miss our exit, or hit a tree because we're going too fast and out of control. Yes, that happened. That's my personal photo, Rick. Get it off there and stay out of my hard drive. Now, new dashboard? This isn't gonna be happening to us. Cloud management from VMware. It just works.
Now, whenever we talk about cloud computing, at first there have to be some jokes involved, and that's because cloud computing is the most overhyped and overmarketed term in technology today. Companies have marketed cloud computing as some utopian computing model, where if you just put everything in the cloud, all the problems of end users and admins will be solved. And that's why I love this Dilbert joke so much. The pointy-haired boss says, I hired a consultant to help us evolve our products to cloud computing. The consultant just says, blah, blah, cloud, blah, blah, cloud, cloud, cloud. And the pointy-haired boss says, it's as if you're a technologist and philosopher all in one. And Dilbert says, blah, blah, platform. In other words, he's not saying anything, but people just seem to love it for some reason. And that's because cloud computing has just been marketed as this heaven of technology. Here's another joke where you can see how you can put your database, your app server, your code, your mobile devices, your PCs, and even the kitchen sink can all go into the cloud. And it says cloud computing, everything and the kitchen sink. One more joke here before we move into Cloud Computing 101. These two guys are looking at their whiteboard and they say, last year we recognized that our processes were far too complex. And they say, so we put them into the cloud, And now you can see the processes have been consolidated just into this cloud where it all goes in, nobody knows what happens, and it comes out the other side and everything's just perfect. Again, the marketing has promised us this utopian computing service, and that's not the reality of cloud computing, I'm sad to say. It does offer so many great benefits, and I do highly recommend that you investigate and start learning about cloud computing. But just like any other technology, cloud computing isn't perfect. So what is cloud computing? Well, according to VMware, cloud computing is an approach to computing that leverages the efficient pooling of an on-demand, self-managed virtual infrastructure. So just as server virtualization abstracts the operating system from the hardware, cloud computing abstracts the business services from the underlying complex IT infrastructure, allowing the business to consume IT as needed, just like they do electricity, to maximize their efficiency. So the backbone of cloud computing is the virtual infrastructure. You're going to leverage your existing virtual infrastructure and turn it into this cloud computing service so that business owners can utilize IT as they need it, when they need it, based on the rules and policies that you implement. Now let's think about the various forms of cloud computing. There's a lot of different cloud computing models out there. I mean, in general, cloud computing is just some kind of hosted service because so many different service offerings are called cloud computing. There's infrastructure as a service, or IaaS, which is really what we'll be talking about in this video training course on vCloud Director. It's all about infrastructure as a service. But also, there's platform as a service, such as Microsoft Azure or Google Apps. There's software as a service, such as Microsoft Office 360 or Dropbox. Then there's desktop as a service. Many companies offer virtual desktops that you can subscribe to. And then there's IT as a service, which really tries to encompass everything. Basically, it's outsourcing your IT department or IT infrastructure to someone else. Basically, they're providing you all IT services. Then there's disaster recovery as a service. In other words, let's say that you replicated a virtual machine from your existing vSphere infrastructure up to a cloud computing company so that you could power on that virtual machine if you had a disaster and get your end users back up and running much faster than before. There's storage as a service. There's storage appliances that you can put into your virtual infrastructure, and then those are replicated to a cloud computing company so that all your virtual machines that were placed on that storage or all your data placed on that storage is replicated offsite. So that's storage as a service, and also disaster recovery as a service. There's many other forms of cloud computing, but again, in this video training course on vCloud Director, we'll be focusing in on infrastructure as a service because that's what vCloud Director provides. Now, to implement cloud computing, you really need to take a step back and think long and hard about the approach that you have to IT at your company. In the traditional IT management approach, services and assets are tied together in a complex, brittle, and vertical stack that's really hard to change and hard to manage. So let's think about the Tier 1 applications at your company. Let's say that a new company is bought, it forms a new division in your company, and they are going to need a new ERP application based on transportation. You don't have that, so what do? Well, you say, we need to buy a new storage area network, some new servers, some new, network switches, UPSs, all this infrastructure to provide for that transportation ERP application for the new division of the company. And that happens every time you add, let's say, new Tier 1 applications. And then when the lease is up on that equipment, it's very difficult to replace it. When the application needs to be upgraded, it's very difficult to test it. For disaster recovery, that infrastructure needs to be replicated to another site, and then you have to find some way to replicate that data or provide offsite backups. It's all very difficult to manage, and that's because it's all very siloed to the specific applications that you run at your company. Now let's think about a new model to managing your IT infrastructure and business applications. Because IT just has to keep pace with the business. IT needs to be ready to provide the business the applications that they need and the infrastructure that they need anytime that they're ready. So service components need to be abstracted and sourced from dynamic resource pools with horizontal layers loosely bound to services. In other words, you use your virtual infrastructure. That virtual infrastructure is dynamic, it's agile, it has load balancing, it has high availability, and you create virtual machine templates. These templates can be accessed by end users, and they already have the applications the end users need on them. Those end users can power on and off the virtual machines based on the policies that you create. Or you might even put in VMware vCloud Request Manager so that the end users can request the applications and virtual machines that they need. You can approve those and ensure that they're deployed in the way that IT has specified. But still, it's all very dynamic, it's all very fast. End users get the applications that they need very quickly. They don't have to wait for you to spec out servers, order them, rack them, stack them, and install their new applications. It's a completely different approach to IT management, but it's the way that IT has to think and the speed that IT has to move at to keep pace with the business and enable the business to make money, not be a barrier slowing down the business's profitability. In other words, IT has to be an enabler that empowers the business to do great things, and this cloud management approach is going to make that happen. Here's another way to look at cloud computing. The business has strict demands of IT. As the CIO on the left, you need to be able to provision the services that the business needs when they need them within your resource constraints. And through cloud computing, you'll be able to do that as cost effectively and as quickly as possible. And as the CEO on the right, you'll enjoy cloud services because they'll provide you the agility that you need to anticipate and respond to change while maximizing IT resources. By thinking about IT as a service that provides the business the competitive advantage that they need, cloud computing can be a great thing for everyone. So what are the different types of infrastructure as a service cloud models? Well, you've got the private cloud. So you take your existing vSphere infrastructure and turn it into your own private cloud. Then you've got public cloud providers who are using vCloud Director to enable public clouds that you can subscribe to and pay for IT services by the minute or based on a commitment of specific IT services every month. And then you can connect those two and create your own hybrid cloud so that you can move applications from the private to the public or from the public to the private as needed, or even connect the two so that servers in the public cloud can work with services, or even connect the two so that, let's say, end users in the private cloud can use applications and services in the public cloud. But no matter which model you're using, vCloud Director is the piece that's going to make this possible.
Get ready to go inside Google's cloud. The tech giant has 12 data centers around the world. They are the engines that make Google run, and they contain a lot of sensitive information about you.
Now, for the first time, the company has invited cameras inside its top secret facility in North Carolina. Michelle Miller went along for this story that you'll only see here on CBS This Morning.
With all the patrols, fences, barbed wire, and steel barriers designed to slice through cars, it would be easy to mistake this place for Fort Knox.
Hello.
But it's really a Google data center.
Yes, ma'am. Do you have your ID on you?
For many years, the company refused to admit these even existed. Even today, no visitor may enter without first signing a non-disclosure agreement.
Just saying that you're not going to take any unauthorized pictures, or you're not going to talk about anything that you see.
Inside, security is just as tight.
Thank you.
Retina scans determine who has access, something even many Google executives don't have. Every single person entering and leaving is tracked. If more than one person enters through the doors at once, alarms sound.
Have you ever had a breach at this facility?
No.
Never?
No. Let's go in.
Our tour guide is Google's Senior Vice President, Urs Holzle, known for his trademark red socks and one of the company's first employees.
My first job title was search engine mechanic, and I picked that because everything was broken. Google was down, searches took 5 seconds.
Now Holzle is in charge of building and running all of Google's data centers.
In the industry, you're known as the infrastructure czar.
Mm-hmm.
Flattered by that?
Yes.
Yes?
Our first stop, the networking room. It's like air traffic control. Every time a user asks Google for something, that request is first routed here and then directed to another computer on the server floor. How many servers are on this floor?
So today we have 55,200.
The sheer size and scale of the place is breathtaking. Employees must wear earplugs to protect their hearing from the constant whir of tens of thousands of machines.
So each of these servers basically is like a PC except somewhat more powerful.
And when one of those servers goes down, we saw firsthand what it takes to repair or replace them.
Okay. Finally, you can plug in that power.
Right here. How about that? Recently, the industry came under fire for being energy hogs, consuming huge amounts of electricity to keep servers running in air-conditioned rooms. On our tour, Google was very eager to show us how they were reducing their carbon footprint here at the data centers. That's because the company is very protective of its green image, according to Wired Magazine's Stephen Levy. He has covered Google for years and also got a tour of the Lenore data center.
The opening up of the data centers really comes from their feeling that they can't keep this to themselves.
Google reduced a lot of its energy consumption by simply raising the temperature on the server floor from a chilly 68 degrees to a balmy 80.
We're estimating that we saved over $1 billion in the history of Google through these efficiency measures.
At Lenore, Google says only 10% of the electricity is not used to power its servers. Another Google innovation, replacing wasteful air conditioners with a water-based cooling system. But for all of the company's efforts to become energy efficient, a lot of their power still comes from non-renewable sources. The power here is coal.
The power here comes from whatever the local utility provides.
Which isn't clean energy.
Which in North Carolina is about 2/3 coal, yes. We are currently at about 35% of renewable energy, and we're aiming to get eventually to 100%.
Google says this is the only time they'll allow TV cameras inside their server floor. But in an effort to be more open, they say they will put up video and pictures of all their data centers on their website.
It's amazing how all of this works and that it works at all. And the fact that they always do is really amazing.
For CBS This Morning, Michelle Miller, Lenore, North Carolina.
It's interesting to see inside, but I wonder if it addresses some of the privacy concerns that people have about Google.
Well, it's interesting you said that because Michelle actually came out with a printout of your whole search history.
We'll be looking at that later.
What is the cloud management marketplace? At the end of the day, it's a single place to go, a one-stop shop where you can get all this great IP from our vendors and partners.
This is a place where VMware and partners can advertise and put their solutions. These solutions could be as simple as a content pack for Log Insight, a management pack for vCenter operations, a blueprint for vCloud Automation Center, a vCenter Orchestrator plugin. These things are crucial for customer success.
For customers, we've made it easy to find the partner solutions in one single place, a one-stop shop, if you will, for customers to come and find solutions that they can deploy with confidence because they've been certified and tested and validated to work well with their VMware management solutions and platform. You can also engage our product teams, let us know the solutions that you're looking for and feedback on the solutions that exist, so it's a very interactive environment.
The VMware Cloud Management Marketplace is a great place to find all the resources that you need to integrate with whatever technologies you might have in your data center. Within UCS, we've already integrated into the Virtual Center console with a vCenter plugin. Additionally, we've created a Log Insight content pack that allows us to take all the rich information generated by the UCS infrastructure and collect it in UCS Manager, and then output that into Log Insight to provide rich analytics.
Through collaborative engineering work with VMware, VCE Vision software has native integration with VMware's virtualization and cloud management portfolio. This engineering collaboration has enabled vCenter operations to evaluate extensive metrics on the Cisco UCS, Nexus, and MDS portfolio, and EMC storage and data protection technologies. This, combined with virtualization-specific information, enables vCenter operations to see and manage a vBlock as a system. This integration has continued with VMware's Log Insight, vCloud Automation Center, and VMware's IT Business Management Suite.
VMware's market presence around server virtualization and now the broader software-defined data center, it's making its way very rapidly into a lot of organizations and data centers. But together with VCE, we're really excited because we can bring a unified joint solution to market. More specifically, we are very excited about VCE's commitment to the VMware management and orchestration stack for the entire vBlock family and portfolio of offerings.
What's interesting about the marketplace is you can see the certified solutions. So for example, Zend has a blueprint that has been certified, which means that it is VMware ready. What's really cool is that means VMware has certified the security, they've done extensive testing on the solution, and they'll actually provide support for that solution as well.
We have multiple solutions with VMware's cloud management products. For example, for VMware vCloud customers, we have an automation orchestration solution with vCloud Automation Center, vCenter Orchestrator, and NetApp Workflow Automation. NetApp systems use clustered data on tap. Clustered data on tap is essentially software-defined storage. It's like the hypervisor for storage. As a result, our storage systems can provide seamless scaling, non-disruptive operations, industry-leading storage efficiency, multi-tenancy, and rich data management capabilities.
We have a very unique solution for cloud management products such as VCO and VCAC, as well as other VMware products. Radware developed its own ADC Fabric, an ADC orchestration tool called vDirect. It allows customers to automate the provisioning of load balancing services for layers 4 through 7 to their virtual data centers from VCO and VCAC. I would say the level of installation and automation that we provide are very unique in the market, in the sense that we are providing a basically hands-off onboarding and load balancing services.
At Brocade, what we're very excited about right now is specifically VMware's focus on management. Because let's face it, data centers are all about care and feeding. It's about expectation management. And so what essentially vCenter Operations Management Suite allows us to partner with VMware over is essentially looking at that care and feeding. I'm not talking about speeds and feeds, I'm talking about standard wear and tear care and feeding stuff that is what keeps your business up. And this allows you to get a baseline of it, look at very small variations, and actually take a very proactive management approach to your IT environment with the benefit of a lot of good data coming from partners like Brocade.
The Dell
Compellent Solution Pack delivers performance analysis and increased insight into storage to help detect capacity and performance issues so they can be mitigated before they cause a major impact in your environment. The Dell Storage Solution Pack provides increased visibility metrics and rich collection of storage analytics for Dell storage infrastructures in a VMware virtual environment. The benefit of this solution is for vSphere customers to get enhanced view into other parts of the infrastructure to prepare them to have the conversation with the appropriate IT administrator. This marketplace is a great place to start to promote and get customers excited about new solutions and capabilities. I believe we need to work together to jointly promote these solutions and educate our customers.
EMC's Unified Infrastructure Manager, or UIM, provides comprehensive management for converged virtual infrastructure, supporting both VCE vBlock and partner-led vSpecs configurations. By integrating UIM with VMware vCenter Orchestrator, you now have a level of integration, orchestration, automation that delivers IT as a service in a consistent, reliable, and cost-effective manner. For customers, that level of cooperation gives them the confidence they need to expand to the next phase of their cloud journey.
We have two different management solutions that we've brought to bear on a VMware environment. So the first is our deep integration with the NSX platform. And our other solution is our vCenter Orchestrator solution. This is a very flexible solution. What we've done is expose atomic F5 actions. Be those actions create a virtual server, create a pool of servers. And that allows the VCO administrator to create workflows to do exactly what they're trying to do in their cloud environment. So we're excited about the marketplace, and we're excited that our customers are going to have an additional avenue to find our joint cloud management solutions. It's a place where a customer can go and find the solutions that are appropriate for to meet their business needs.
We integrate with several VMware products. That includes the vCloud Automation Center, the vCenter, as well as the vCloud Director. And with all of these integrations, we have integrated using the vCenter Orchestrator tool. So our plugin actually works with the vCenter Orchestrator and works on providing automated IP address management solutions to the vCloud Automation Center or vCenter, as well as the vCloud Director products.
We at SaltStack are laser focused on providing data center automation and configuration management support for any cloud environment. And so we recognize the presence VMware has throughout our customer base, and our customers are asking for more SaltStack support and integration for VMware environments. VMware represents a significant portion of the enterprise market in terms of private and public clouds and beyond that. And so we understand that our target demographic has a long and productive history with VMware, and our providing support for the VMware suite of tools will enable us to better serve their needs.
So HP Storage has been a leading partner with VMware for over a decade. And based on that strength and the successful partnership between the two companies, I think we can say that we together deliver proven virtualization solutions really spanning the desktop to the data center and also into the cloud. So one of our newer solutions in the VMware Cloud Management is the HP Storefront Analytics Pack. This is an VCOps adapter which enables VMware administrators to get performance metrics directly from 3PAR StoreServe into VMware VCOps. Benefits are really twofold and extend the benefits customers get from VCOps, which is one, being able to determine optimizations easier, and secondly, being able to troubleshoot performance problems.
One of the exciting solutions that we are working on is Management Pack for vCenter operations to deliver into our Hitachi UCP integration. These solutions allow customers to have an integrated approach to troubleshoot and do root cause analysis in a vertically integrated stack with Hitachi UCP Pro and horizontally across other Hitachi solutions. This integration will allow customers to order storage as a service through a self-service portal through the X as a service interface in the vCloud Automation Center.
Puppet Labs is excited to partner with VMware around the vCloud Automation story. Specifically, we're working with VMware on integrated solutions around vFabric Application Director and vCloud Automation Center. As a user, you can deploy multi-tier, complicated applications through a drag-and-drop interface on vFabric Application Director. Puppet and the power of what Puppet can do via the workflow process of going about building those applications and managing those for compliance is a key component of the overall story.
Avnet Services, we do not focus on one particular VMware product. Instead, we feel it's more important to facilitate the data integration capabilities of VMware data targeted to many multiple different frameworks. For example, our latest VMware data integration product, the vCenter Orchestrator to BMC ITSM Remedy plugin, can bridge the gap for a corporation from their virtual layer to their IT service management system. This product enables vCenter Orchestrator workflows to automate otherwise manual IT processes and enable process and data integration based on ITIL standards.
As a partner, the VMware Marketplace really now provides us the confidence that when we put our solutions there, that it gives us the ability to be able to have one place that customers can go to be able to have these solutions delivered.
What we're trying to drive ultimately is customer success. We won't succeed unless our customers succeed. And the way to do that is to make sure that the solutions, the products that we sell are implemented successfully and deliver on value, ROI, low TCO. And the fact is, because they're coming from these vendors, you can trust them. That's really important. You can trust them. You can download them, put them into your operating environment today, and you're going to be successful. You can trust this content.
Hi, my name is Brett McGowan, and I'm a software developer here at Rackspace. Today, I'm going to be walking through how to set up cloud monitoring for your application on the Rackspace Cloud. Cloud monitoring is a quick and easy way to set up monitoring for your application 24/7 from different geographic regions to make sure your response time is good, your servers are up, and your application is performing properly. So I'm going to walk you through how to set up some of these in the control panel. I have here the Rackspace Cloud control panel, so I'll go ahead and click on this server, my blog, that I want to set up a monitoring check for. So this pulls up the information about my server. I'm going to scroll down to monitoring checks, and you can see we don't have any monitors set up right now. So the most basic one we're going to set up right now is called a ping check, and that's just going to send an ICMP packet to the server just to say, hey, are you alive? So nothing fancy, just a quick ping check. So I'm going to say ping check. It automatically knows the IP address of my server. I'll hit create check. And once that runs through, that should be it. It's ready to go. It has been set up. So now every 60 seconds, it'll ping your server just to say, hey, are you alive? And if it fails, then it'll let you know. And it'll ping it from 3 different regions, Dallas, Fort Worth, London, and Chicago. So that's a great way to make sure your app is up from all 3 of those different locations. So in addition to a basic ping check, you can do some more advanced things using the HTTP check. For example, you can make sure text on a web page shows up properly. If you have an e-commerce application, you can make sure your most popular products are available and can be added to your cart. Or you can have the check log into your application and make sure your authentication system is working. So let's take a look at how to set up a simple HTTP check. So let me scroll back down to the monitoring checks. I'll hit create check and change it to HTTP check for the website. I'm going to name it and put in my URL. So I've set this up for my URL, and I'll click advanced options. So under advanced options, this is where you can put in some text that it actually is going to look in the HTML source of the response that gets back from the server. So a good way to check something is to make sure that the footer, for example, on your website, text comes back, and then that way you know that a bunch of things are working. Your web server is working, that it's going to your application and pulling out whatever data that it needs. So I know that on my blog, for example, the footer says proudly powered by WordPress. So I'll paste that in there. If you click on the more on syntax link, that has a lot more information about some really powerful regular expression matching and different things like that you can do rather than just plain text matching. But even just the plain text matching is pretty powerful. So I'll go ahead and create that. And that's going to set up a couple of different what is called alarms. So there are 3 different criteria that it's checking. 1, the body match, string not found. So that's what we just set up, looking for that footer text. So I'll click that, say edit criteria, and you can kind of read through some of the code that powers that alarm. So again, if you look in the documentation, it has a lot of additional things you can check for, such as response code 200. So if it got a 404, then you could throw an alert because the page should be found, but it's not. So I can hit test alarm, and you can see that it passed. So everything looks good there. I'll save that. And again, the other two were set up automatically. The status code is looking that you get a successful and OK 200 HTTP status code, and the connection time is just making sure that your server responds in the appropriate amount of time. So that was an example of a pretty easy to set up but powerful HTTP check. For more information on advanced monitoring, a Python and Ruby library you can use in your application, and more information about the API, you can go to docs.rackspace.com and look for cloud monitoring. Thanks for watching, and sleep easy knowing that cloud monitoring is watching your application.
Hello, and thank you for viewing this video segment titled Managing Security in the Cloud. I'm Linda Stadtmuller, Program Manager for Business Communication Services at Frost & Sullivan, and I'll be your host today. This is our third video in a three-part series on cloud computing featuring our IBM cloud leaders. Rick Telford, Vice President, IBM Cloud Services, Rich Kuchera, Distinguished Engineer and Chief Technology Officer for Business Continuity and Resilience Services, and Chris Lovejoy, Vice President, IBM Security Strategy. We hope you find this discussion engaging and relevant, and we encourage you to view the other two videos in the series. Video 1, Getting Started with Cloud Computing, Choosing the Right Workload to Put into a Cloud Environment. And Video 2, Ensuring Your Cloud is Available and Resilient. Okay, let's get started. Chris, enterprises always name security as their top concern about the cloud. I'll cite a few statistics from the recent IBM risk study. 77% of respondents believe that adopting cloud computing makes protecting privacy more difficult. 50% are concerned about a data breach or loss. And 23% worry about a weakening of corporate network security with cloud computing. What are the greatest security threats in cloud computing, and how do they differ from security threats to a private data center?
Okay. All great questions. I'll try to keep them all in my head. So to start, looking at cloud computing is really not significantly different than looking at hosted computing, or alternatively looking at computing in an enterprise where there is a hyper-virtualized infrastructure. So essentially, there isn't that much difference. I mean, there's a nuance. So from what do we worry about when it comes to cloud computing? Well, particularly with public cloud computing, we worry about loss of governance. Once we cede control to a third party, there's things we just obviously can't control, we worry about. That said, the specific things that are different that we would worry about in a cloud computing environment that we wouldn't worry about ordinarily include things like lock-in. If the cloud provider goes belly up, for instance, what happens to my service? What happens to my data? Is it accessible to me? If the contract terminates, is that data, is that service available to me? Can I migrate to another provider? Second thing that we worry about is isolation failure. This is an infrastructure level issue associated with data storage, networking capacity, and the ability for the provider to actually keep isolation between multiple tenants. Another thing that we particularly worry about is the management interfaces. Interestingly, within the cloud environments, we tend to make management interfaces available remotely over the web. And what happens is that these management interfaces can be vulnerable because most security issues today are focused at the application layer. So that's one of the areas that customers need to worry about. Another area is the data deletion, is the fact that data is persistent, and in a cloud environment it's not going to go away. And so we have to recognize that specific control needs to be placed around the data so that if the contract terminates, you can be assured that it is gone. Another issue is the malicious insider, particularly within a cloud environment. When you realize that the bulk of security incidents are related to insiders either maliciously or inadvertently causing harm within the organization, and you recognize that within the cloud environment that malicious insider has a bigger span of control than they ordinarily would have in a heterogeneous environment, it's something to watch. And then last, there is a bit of a compliance risk. So many customers are worried about what does it mean to comply within a world where my data is flowing cross-border.
Chris, that's some really good points there, especially around the data deletion, because that's something that we've grappled with too within BCRS, is how do we ensure that once we have data, that we have the ability, of course, that once it needs to be deleted, to actually delete it and scrub it. Our information protection services are designed for customers to back up their data, but likewise, you have to be thinking about the life cycle management. So, as Chris had said, not only do you want to back up the data, but when you want to get rid of it, you have to absolutely make sure you get rid of it, because you do not want data to be hanging out and to be accessible somehow later by somebody who inadvertently accesses it.
That's a lot of risks we've talked about, and despite the risks, over 40% of enterprises are using or are planning to use cloud services, according to a Frost & Sullivan survey. Can the risks be mitigated, or must enterprises only place low-risk workloads in the cloud?
My perspective is that a cloud can be more secure than a traditional environment, a traditional enterprise environment. Let me explain the why. So if you think about a traditional enterprise environment is a hodgepodge of different devices requiring lots of subject matter experts who are using specific tools to manage that infrastructure. A cloud computing environment is managed centrally, which means that you can apply a policy from the top and push it down and assure that the policy is applied equally across all of those resources and that those resources can be centrally managed. So when you recognize or realize that service management and the adoption of just basic good practice, top-down policy management equates to security success, what that also indicates is that a cloud environment well managed equals better security. Another area that we believe that security offers benefit, tangible benefit from a security perspective, is in the compliance and audit front. Now, most service providers, cloud providers, have implemented a level of logging and auditing that many organizations, traditional enterprises, can't perform themselves. They can't perform it because the tools and the expertise necessary to do that logging and auditing is hard to come by, and it's also expensive to actually store the data. And so that is a second area. The third area is on centralized security management, so patching, updating, centralized management of those systems. This ties back into my first point about overall services management, but the ability to sort of ubiquitously deliver security control to all of your assets immediately is something that's it's a very compelling statement. And so what I would say is that when it comes to low-risk workloads versus high-risk workloads, yes, you have to consider, is my workload ready for a cloud? But what I would suggest is that, with the right provider, the right SLA, and a good fundamental understanding of what that security architecture is, that the cloud can actually offer a better benefit from a security, what you spend for your bucks perspective than a traditional enterprise.
And I think also, Linda, that from a risk mitigation perspective, in addition to security, the availability is a big issue for a lot of our customers, of course. So cloud providers are going to give them the ability to have a higher level of availability. Because right now, if you're a company with a single center, or even 2 centers in a small geographic location, your risk is pretty high. Okay? So the only way you can mitigate that risk is to either build yourself another center somewhere else, or utilize a cloud provider who can give you that capability on an ongoing basis, and you can use it and consume it as you need without having to build that. So I look at cloud as helping to really mitigate a lot of risks that otherwise could not be mitigated except through some very expensive infrastructure building.
Well, let me end with a question that I'm sure is on the minds of a lot of our viewers. How does IBM advise clients to get started in developing and executing a cloud security strategy? Chris, do you want to start?
Sure. You know, what I would say is there's a few simple steps. The first step is to look at the workload and identify the risk profile for the workload. So look at the data and the sensitivity of the data, look at your availability requirements, look at your compliance requirements, and determine, you know, what kind of profile does this particular cloud have. Second thing is engage an expert to help you build a secure cloud strategy. Now, when I say secure cloud strategy, I'm not saying a cloud security strategy. It is a cloud strategy with security interwoven into the fabric of the design, because security has to be an aspect of that overall program. It can't be something like we generally do, bolted on after the fact. Third thing you do is you negotiate a good SLA. Now, one warning about negotiating a good SLA is that if your provider is too willing to negotiate, what that indicates is that there may be a lack of table stakes, if you will, that have been implemented within the cloud. And so what you want to make sure of is that the SLA explicitly defines your responsibility, the provider's responsibility, what they are implementing, gives you, yes, some level of flexibility, but also, you know, looks at the standards. And then the fourth thing is, once you have contracted with the provider, routinely assess your internet-facing applications, and if possible, assess your management interface as well. So those are really what I would say are the keys to sort of going down the path of looking at security, cloud design and implementation.
Let me echo what Chris just said. I mean, when I'm working with a client and they're interested in going to cloud, the first thing I ask them, of course, is, you know, what are you worried about? What's keeping you up at night? What are the risks? What's the risk profile that you do have? And by understanding that, then we can create an architecture that works for them. Combination of their own infrastructure combined with our infrastructure. As Chris said, interrogate the cloud provider. I mean, who is it that you're working with? What is the service level agreement going to be looking like? How robust is their infrastructure? What are the backup and recovery capabilities that the cloud provider has? Where are they located? I mean, for us in BCRS, I mean, we have 164 locations around the world. So that is of great interest to our clients because, as Chris said, where are you going to put your data? So I ask the customers all the time, look at the risks that you've got, create an architecture that works for you, but when you're creating this hybrid architecture, combining yours with a cloud provider, make sure that the robustness of your cloud provider is as robust as yours, if not greater, because risks that you have that you need to mitigate, the cloud provider should help you do that. It shouldn't go the other way. You shouldn't be more risky than you were before.
I'll add to that. I think it's implied in what Chris and Rich said, but I think to render explicit, when you're doing that strategy, it should be holistic in nature, and it needs to look at all aspects of security. And so IBM's been, you know, in the business of securing data centers for, you know, for 40, 50 years, and so we've developed best practices, the IBM Security Framework, and you basically go through and you look at access control, you look at identity management, you look at data privacy and data security, you look at network, you know, what's your network policies and endpoint security, physical security, application security. All those things should be part of your cloud security strategy. Just don't focus on one aspect or the other. The cloud, just like any other part of your IT data center, needs to cover all aspects of a security framework.
Well, thank you to our panel and to you, our viewers, for joining us today. Please look for the other videos in the series, and for information on cloud computing, turn to www.ibm.com/cloud. Thank you.
So I'm here to talk to you today about McAfee's new cloud security platform. So you have the enterprise down here with mobile users, users behind endpoints, and then applications. All of these are communicating with the cloud over 3 basic channels. You have the web channel, you consider this content and web applications, identity and access control, and then email. These 3 really represent communication, collaboration, and transactions to and from the cloud. So here's where McAfee's cloud security platform really provides value to the enterprise. Basically modules that represent this platform in unifying the security across those 3 channels. So you have data loss prevention, web security, email security, all provided by McAfee. These are solutions that McAfee has on the market today. But they're integrated in this platform with Intel's Cloud Access 360, which basically provides cloud single sign-on to different assets in the cloud, as well as the ability to provision users from the enterprise into cloud assets like Salesforce and Google. But additionally, we also have Intel's Service Gateway, which provides security on top of the APIs that the enterprise uses to communicate with the cloud. So this is the McAfee Cloud Security Platform, solving the challenge for the enterprise in securing data going to and through the cloud. To learn more, you can go to mcafee.com/cloudsecurity. Thank you.
Cloud computing is being widely adopted across many industry sectors. With adoption comes security concerns, but there are ways to ensure privacy and prevention of data loss. We will tell you how to overcome data security challenges in the cloud. Cloud computing is experiencing significant growth with rapid adoption among various regions around the world. By deploying cloud technology, most organizations have managed to reduce total cost of ownership, increase flexibility of IT implementation, become more competitive amongst emerging players, and meet time-to-market objectives. While cloud technology provides business benefits, there are a few challenges as well. Data residency and data security are key concerns when moving to the cloud. The main concerns with data residency are who manages and has access to the data, where's the data stored, and what laws apply. Will you know when data is breached? Will data remain in the cloud even after termination of service? Data encryption and tokenization are the key solutions to overcome data residency concerns. Data encryption is the mathematical process of converting clear text data into ciphertext, which cannot be read by anyone other than the customer who retains the encryption key. In tokenization, actual data resides locally in a token database. Randomly generated tokens are associated with the data and are sent to the cloud. The data can only be read by the custodian of the token database. The significant differences between tokenization and encryption are tokenization protects only against external threats, since anyone with access to the token database could access clear text data, whereas encryption protects against internal and external threats, since there is segregation of duties between where the keys are managed and where the encrypted data is stored. Tokenization requires higher capacity servers and databases and more operational oversight to manage the critical token database that grows with increasing data volumes. Encryption requires lighter weight stateless servers with no data storage. With our experience in cloud enablement and as a cloud visionary, Capgemini, in partnership with CipherCloud, provides secure deployment of any organization's cloud applications. This helps organizations shift focus from technology challenges to improving business performance. The collaborative solution provides secure cloud enablement and deployment, meets privacy and residency regulations globally, and is deployable for multiple cloud applications in the enterprise. Join hundreds of companies in numerous sectors which have deployed Cipher Cloud to secure data and depend on Capgemini for the cloud transformation. For more information, visit capgemini.com/socialbusiness/Salesforce Solutions.
People matter, results count.
45% of all businesses that experience 10 or more days of ongoing disruption in business continuity never recover and usually go bankrupt. Cloud computing provides automatic data, application, and system backup stored in multiple locations. With cloud computing, following the worst of natural disasters, your business can continue critical business processes such as CRM, financial like QuickBooks, inventory, email, and voice telephone service within minutes. For example, if the worst possible disaster like Hurricane Sandy hits your location on the East Coast, the computing systems of your business could be fully operational within minutes by retrieving duplicate systems with virtual servers, application software, and data which have all been backed up in real time from data centers located on the West Coast. Cloud providers can offer preventive measures that most business owners cannot afford to implement themselves because the cost is too high. SAS-70 or SSAE-16 enterprise-grade data centers that cloud providers use for backup are often deliberately built at locations that experience fewer natural disasters and located where they can tap into redundant sources of bandwidth provided by varied transport modes and multiple carriers, so that if one bandwidth source goes down, automatic failover systems provide access to bandwidth alternatives in real time. Cloud providers can afford to utilize the most robust security tools that include multiple layers of logical and physical security, including biometrics. This prevents unauthorized use of data and theft. Cloud providers are also able to utilize state-of-the-art uninterrupted power supplies, UPS power backup, and top-of-the-line backup power generators. With cloud computing, you get service-level agreements, SLAs, that can provide a written guarantee that key components of your IT system will be back up and running within 2 hours of a disaster. With cloud computing, your business continuity can continue or resume within hours rather than days, weeks, or months. If your building is totally destroyed or you cannot obtain access to it, you and your employees can use laptops or mobile devices such as tablets or smartphones to resume critical operations such as customer service from any remote location where internet service is available within minutes of the disaster. If your company has been utilizing cloud-based hosted PBX for telephone service during the normal course of operations, you and your employees can actually take your IP phones with you when evacuating for the disaster and resume normal telephone communications from anywhere in the world where they can obtain internet access. All telephone features such as voicemail, call forwarding, conference calling, etc. will remain fully functional. If your company uses virtual desktops, another great offering of cloud computing, you and your employees will have full functionality of the most recent Windows operating system from any mobile device at any evacuated location that has internet. Thanks to national defense level encryption offered with cloud computing and the fact that none of your company's vital data will actually be stored on the mobile device, but instead is stored on a secure server located at a secure location, your mobile device will simply serve as a portal to your secure network. Use of virtual desktops on portable devices is often more secure than the security systems you use at your business location. By utilizing cloud computing, regardless of where you and your employees evacuate to, you will sound and appear to your customers like you are still sitting in the office you evacuated from, with the full functionality of that office, even if you are sitting in an internet cafe, enjoying a cup of coffee while you are working. With a good disaster recovery and continuity plan, your business will not need to experience significant downtime while your permanent IT system is being restored. Customers can be assisted immediately. There will be no loss of valuable data. Thank you for joining us for this discussion. If you have questions or if you would like a free consultation with one of our certified engineers, please give us a call or use the contact form on our website. A link to our website is located immediately below this video.
If you would like to watch other videos which address related topics, please click on one of these green links. Or click the link directly beneath this video to use our patented real-time pricing tool. This pricing tool is easy to use and there is no obligation. Our pricing tool will assist you in checking prices and availability for any business telecom service for your business location, including T1, Ethernet, fiber, voice, VoIP, larger circuits like DS3, Fast-E, or Gig-E, or networking between business locations for any location in the United States or international networks. Please visit our website at www.fiberlinecommunications.com. I'm Jody Ellen, the Director of Training here at Fiberline Communications. Thank you for joining us today for this training session.